DTU Wind Energy operates some of the most advanced test and research facilities in the world. Researchers and companies can test everything from nanoscale materials, large-scale structures, to full demonstration of turbines. Introducing 3 of our flagship facilities, starting with the Poul La Cour Tunnel. It is the largest university-owned wind tunnel in the world.
Now we are standing on the top of what we call the test section. So below we have the wind that can go up to 400 kilometers an hour and test different models.
The wind tunnel is a closed return tunnel. The fan is driven by a 2.4 megawatt motor, giving a wind speed of around 380 kilometers an hour, similar to 3 times a hurricane.
The nice thing with the wind tunnel is that everything is controlled. If you go to the field and test a wind turbine, the flow will be super turbulent and fluctuating, and you will have a hard time measuring what's actually coming to the turbine. Here, things are constant. We can change the parameters as we like, and in this way, we can test the you can say components of the blades part by part and be in control all the time. And that also means that we can accelerate the design. So if we had to make a design change, go to the field and test it, then we had to make a complete blade, test it for a long time because it is difficult to measure. Here we can do it pretty fast and also very dedicated in a short time.
Onto the large-scale facility. Here researchers perform advanced structural tests and loading of turbine blades to provide accurate data about strength, reliability, and fatigue.
We built this place to do research projects. We need places where we can play with technologies, where we have time and the facility to try things out. We try it out and we see problems and then we try to solve them. When we have a strong research environment here with some really good researchers with many different expertise and knowledge, then that's a perfect group to solve these problems and find solutions, and then we can try them out here. And we can do that on small blades, and then we can demonstrate it on larger blade. We can go up to this blade, for instance, which is almost 50 meters. But the biggest blades, of course, are much bigger, and industry is usually taking the last step of taking the technologies from this demonstration level to full commercial level. I'm passionate about structures. I mean, I've worked with structural engineering all my life. And to make structures better, safer, understand how they fail, and be able to hinder that with designing them better, and also to pass that on to the next generation of engineers that will take this further.
Our third flagship facility is Østerild. It is located at the west coast of northern Jutland. Some of the best wind conditions in the world allow the manufacturers to test full-size turbines before they enter the market.
Østerild has the huge advantage that it has really good wind for actually these kind of tests we are doing. It has a really high winds, but also the low winds, so it has good spread. And that means if the manufacturers are doing a change in the turbine, it could be hardware, it could be software, they in really short time have the response from the turbine. They get new data in saying, okay, we tweaked there, it gives a little bit more power there. They get that answer right away.
Due to the close proximity to the North Sea, Østerild is perfect for testing offshore turbines. The test stands have capacity to test the new generation of megaturbines up to 330 meters tall.
Generally speaking, we are testing the prototypes of the manufacturers. And for those prototypes, they need to be verified and certified to be able to be sold. And for that, they need some standardized tests. We are doing those standardized tests. It's a performance test and a load test, so how much the turbine is physically loaded. And those tests we are doing in Østerild mostly and in Høsøre. And the thing is that the manufacturers, they say they want a new turbine, saying they want this target size, then they design it, and then they build it, and then it comes to the big test of, does the turbine work? Does it produce what it's needed? And is the loading of the turbine as planned? And for that, they hire us sometimes, and we go at Østerild, we put on the instruments, and then we do the tests.
Other facilities include the Composite Materials Lab, the wind scanner, the rotating test rig, and the V52 research wind turbine. At DTU Wind Energy, more than 250 employees of 36 different nationalities work with research, innovation, scientific advice, and education. We are a global knowledge hub for wind energy research, and we collaborate with companies and research organizations from around the world to develop the most effective wind energy technology on the planet.